Okay, this lecture is going to be over some pretty basic concepts of bones. You should pretty much already know a lot of this based off of anatomy and physiology. So I'm going to try to highlight a few areas of importance. So first, let's look at the full skeleton here. We need to be able to differentiate between the axial skeleton and the appendicular skeleton. Which bones go to each? So the axial skeleton, you're going to have your skull, vertebral column, sternum, rib cage. That's your axial skeleton. Appendicular, everything else. So probably an area where people might, have the more like 50-50 shot on a multiple choice exam. Let's look at the clavicle here. This is where things start to become appendicular skeleton. Then on to the scapula, humerus, radius ulna, all the way down to the hands. And then also down in the lower extremity, the pelvis is not part of the axial skeleton. But look in here, what about the coccyx and sacrum? They are. So just remember that. Easy questions on a multiple choice exam, differentiating between axial and appendicular skeleton, making sure those parts right at the border, that we know which ones belong to which. So let's take a look at a basic long bone here. On the diaphysis and on the outside, you have this real thick, compact bone. And then in the middle, you have your medullary cavity or canal, depending on which text you see it in. And the diaphysis is the long portion of the bone. The epiphysis is going to be the ends of the bone. Where the bones articulate, you're going to have articular cartilage. So right here, this is which bone? This is the humerus, if you didn't know that. So right here, you have the head of the humerus. It's going to go into the glenoid fossa of the scapula. So we have cartilage here. Hyaline cartilage. So it's going to cover the ends of bones where they articulate with other bones. Now let's look at some different types of bones here. And all of these pictures are from your PowerPoint slide, by the way, so you can go to town on that. So we're looking here. Let's look at A. You can see that that is short bones down here. So you say like the carpals in the hands. Then you have long bones, so like the humerus, or the femur, the radius, the ulna, the tibia, the fibula, all would be examples of long bones. Clavicle. Then we have our sternum. It's going to be your flat bones, so the whole sternum. Manubrium, xiphoid process, and what's this? See if you can remember. If not, look it up. We have irregular bones. So we have your vertebrae. And a sesamoid bone, a little special. So this here is the patella. And as we get to different parts of the body, we'll talk about other sesamoid bones. But what makes a sesamoid bone unique is that it is embedded in the tendon or a tendon. So there's a couple others we'll talk about throughout this term. But that's what makes something a sesamoid. So now we're going to talk about joints. So you have bones. Bones, if you have more than one, articulate to form a joint. So there are multiple kinds of diarthrodal joints But these are the three main classes of joints. And within those classes, especially the synovial joint, you'll see that there's tons of different kinds. So first, let's look at the skull. You have the synarthrosis right here. What makes these joints exist is the fact that they are fused together with sutures. So they don't really move. It's a synarthrosis joint. Then you have the amphiarthrosis. Honestly, right now I can't spell amphiarthrosis. So, and that is going to be between the vertebrae, because you have a big disc in between those. That's what makes it an amphiarthrosis joint. And then the one that that's most common is going to be your diarthrosis joint. Now, what makes these special and separate from the other ones is you have the joint capsule and synovial fluid. That's a little blurry on that there. But a joint capsule that contains synovial fluid. Synovial fluid is the lubricating component that helps maintain good joint health. It carries nutrients, keeps it fresh, and like I said, it's a lubricant. So that's what makes a diarthrosis joint, is it has that synovial fluid. So synovial joints or diarthrotic joints, these are the different kinds. So you should know which joint, if given a joint, goes into which. The one I want to really point out here is the difference between hinge. Looks gross. Let's go hinge and condyloid. So if I ask you what would be an example of a hinge joint, a lot of you will say the elbow, and some of you will say the knee, and that's incorrect. The knee is actually a condyloid joint. So your tibial femoral joint is a condyloid joint. You're thinking, but it only flexes and extends like a hinge. That is true, it does that, but it also does a little bit of rotation. And that rotation is a key component of the screw hole mechanism, which we'll talk more about at the knee, that helps lock the knee. Without that rotation, you don't have the screw hole mechanism. So technically, the knee joint goes through two planes of motion. That's something else we should be paying attention to. Look at these degrees of freedom. These are your planes of motion that it moves through. So we have that video on different planes and axes. So this is what it's talking about. A hinge joint moves through one plane. And if you think about the elbow flexion and extension, what plane does elbow flexion and extension move through? Hopefully you said sagittal plane, because we're basing it off the anatomical position. Now, if you have watched those videos, let me ask you, the rotational component of the knee moves through which plane? Hopefully you said horizontal plane. If not, then you need to watch that video again. So make sure you know which joints go where to answer easy questions on the exam.